Okay, Trig, this is the second half of section 10.5 where we started talking about vectors. For the first time, actually. I've never talked about vectors before, but so far they seem to be pretty easy. We left off with vector addition and vector subtraction. Okay, so remember that when they have the triangular brackets here, this means that this is the direction that it's going. So this is kind of taking into consideration two coordinate points here. This is going to two coordinate points like if you're starting at 0, 0, you would be going to negative 5, comma 2, which means you are going to the left 5 and up 2. Okay, so it's kind of taking those two coordinates into consideration by putting them into triangular brackets. And this will mean left 5, up 2. Okay, this guy will mean right 3 and up 1. Okay. And what they want us to do is they want us to basically add those two vectors together, which we showed what will happen to that yesterday. Basically, if you have one vector like that's saying going this direction, and then you have the wind that's blowing this way, you might end up with a ball actually, going in a different direction than before. Okay, so what will happen if you have a negative 5, and then it's going to the right 3. So you have a negative 5. Maybe this would be your wind, and this would be the ball that was thrown. What's going to happen is when you combine those two together, negative 5 and 3, it will end up in the negative 2 direction, okay? And 2 and 1, it's going to still travel up, but it's going to travel up 3. So it's basically adding these two pieces together. You're adding your x's and you're adding your y's. Okay, that's kind of how the formula here is set up. You're adding your a and c together, and you're adding your b and d together. Okay, and so that's what u plus v would look like in component form. Okay, it's going to end up, this vector is going to end up at negative 2, comma 3. Okay, this is just an example. That's not actually what negative 2, comma 3 looks like, but there you go. Okay, vector subtraction. It might help to write the subtraction out so that you can not forget to distribute the negative through. So if we start with 2, comma 5, and we are subtracting 6, comma 1, okay, what we're going to do is we're just going to subtract each of the coordinates. So it would be like 2 minus 6, or negative 4, and 5 minus 1, which would end up being at 4. So we're adding or subtracting those two vectors together makes it really super easy, okay? I also put a little note down here that the 0 vector is also called, is the vector 0, 0, which is denoted as 0. This is basically saying that we're not changing him. He's not going to the right or to the left, and he's not going up or down at all. That 0 vector is like no wind at all, basically. And they call that the 0 vector, okay? All right, let's go to the back side. Now they give us a little bit more complex numbers, but it's kind of the same scenario. So they say 2u plus 3v, okay? So now we have that 2 and that 3 represents that scalar multiplication that we had on the front side, or on the last page, scalar multiplication, and then we're also doing some vector addition at the same time, okay? So if I write out each one of these vectors in place of those, I'm going to do 2 times negative 1, comma 6, because that's what u is, right? Plus 3 times v, which is 2/3, comma negative 4, okay? And so don't try to do this all at one shot. Some of you I'm sure can, but I go ahead and write all my steps out. So if I take 2 and I multiply him through, that would be the vector negative 2, comma 12, okay? 3, if I multiply him through, 3 times 2/3, okay? I have a lot of you still, maybe not in this class, but some other classes that don't know what 3 times 2/3 is. This is like 3 over 1 times 2/3. The 3's will cancel out, so that's just 2, right? Okay, so I have plus 2, comma, and then 3 times negative 4 is negative 12, okay? So anytime you have, like your tops and your bottoms are the same, just cross them out, and it's just this number at the top, okay? All right, now I'm going to add those two together. So I have negative 2 plus 2, which will give me 0, and 12 plus negative 12, which is also 0. So that's that 0 vector that we just got done talking about. So basically, if I combine these two forces together, it will give me a 0 vector, and it will not end up going anywhere, okay? So B Same thing if I write him out. So I want 4w, and w is 2 comma 5 halves, okay, minus 2, and I have u, which is negative 1 comma 6. Okay, so I write all that out, and then I distribute. So 4 times 2 is 8, and 4 times 5 halves, okay. If I make this 4 over 1, I can reduce that to 2 and 1. Right? 4 and 2 will become 2 and 1. So 2 times 5 will give me 10 in that scenario, in that case. So 8 comma 10 will be that vector, and then minus 2 times negative 1 is negative 2, and 2 times 6 is 12. Okay. Now, if you wanted to go ahead and distribute that negative with the 2 at the same time, you could change this middle sign to plus, and that's okay too. I just left it as a negative, but it's fine. So 8 minus a negative 2 is going to be like 8 plus 2, which is 10. And then 10 minus 12 will be a negative 2. So that's where my final vector is going to end up when I add them together. Okay? All right, example 7. This is where we're trying to find the angle that's formed. So this is going to involve sine, cosine, and tangent. And it says the initial point is at the origin. Okay, so that's important to remember. I'm going to start with negative 3, 4. So if we're starting at the origin, negative 3 means I'm going to the left 3, and 4 means I'm going up 4. So he's going to end up here, and my vector is going to look like this. Okay, so it's going to be kind of similar to what we've done before, where we make him into a triangle, and then we try to figure out what his angle is. Okay, so this angle right here, we can use SOHCAHTOA and figure out what he is. Negative 3 is going to be this side, 4 is going to be this side. Okay, and really this will make a negative 3, 4, or a 3, 4, 5 basically triangle. But in this scenario, we really don't have to know what that hypotenuse side is because we could just use tangent, right? Tangent is opposite and adjacent. We don't really need to know the hypotenuse side. We could if we wanted to, but I'm just going to use tangent and negative 3 and 4 to figure out what this angle is right here, okay? So tangent of some angle, let's call it x, or you can call it theta in there, we're trying to figure out what that is opposite, which is 4, over adjacent, which is 3, okay, or negative 3. And then how do we solve for x, or how do we get the x in there by itself? We're going to take the inverse tangent of both sides. Okay, so x is going to be equal to inverse tangent of 4/3. 4/3. Oh, shoot, hold on. Inverse tangent of 4 over negative 3. It will make a difference. Okay, and that is negative 53.13. Blah, whatever that means. Negative 53.13 degrees. Okay, and that negative really doesn't matter so much, except for the fact that since we're in the second quadrant, tangent will be negative. So that's kind of how that angle comes into play. But they're saying that this angle right here is 53 degrees, okay? Or 53.13 degrees, okay? Now, I'm not going to leave my answer as 53 degrees because we want from standard position. This is where it's going to trick everybody. From standard position. Standard position means from here over to this way, okay? How many degrees would that be? If this is 53 degrees, how many degrees would here over to here be, okay? Well, I know from here all the way around to this bottom side is 180, and if this is 53, I could just subtract them, right? Okay, so 180 minus the 53.13 degrees, that will give me actually the angle in the second quadrant that I'm wanting, okay? So 180 minus 53.13, yeah, that will give me 126.87 degrees. That's how I want to write my final answer, because they want to go from standard position. If you just tell me 53 degrees, I'm going to think you're talking about 53 degrees here, right? But 126 degrees I know is in the second quadrant, right? Okay, so that's how I'm going to do that, all right? Next one, 1 and negative 3, we're starting at 0, and we're going to the right 1 and down negative square root of 3. Okay, I'm going to make this a little bit bigger. Let's say 1 is over here and negative square root of 3 is over here. So we're going to make him like this. Okay, draw his other side here. So we went to the right one, and this is a negative square root of 3. So he is down over here in the 4th quadrant, and we need to figure out what this angle is. That's what we're trying to find. Okay, we really don't care about what this hypotenuse side is because we could just use tangent again. This will be my opposite side. This will be my adjacent side. So I could do tangent of, let's call this guy x, equals opposite, negative square root of 3 over 1. And, well, that makes it kind of nice. Hold on just a second. Negative square root of 3 over 1, that is on the unit circle. I could just do that. So when we're doing this, we're trying to find where on the unit circle tangent is the negative square root of 3, basically in the 4th quadrant, right? Okay, so, oh, this isn't the right unit. Oh, yes, it is. Yes, it is. Right here. Tangent, tangent is negative square root of 3 at 300 degrees in the 4th quadrant. So then I don't have to subtract anything. I can just say 300 degrees. There you go. Okay. If you want to do this on your calculator, you sure can. We would do the inverse tangent again. Inverse tangent. So second tangent of negative square root of 3. Come on. Did I do something? Oh, negative square root of 3. I didn't like the minus sign. They're saying that that's 60 degrees. So this angle right here would be 60 degrees. But I want to know from here all the way around. And if this is 60, I would take 60 degrees and subtract from 360 to get 300 degrees. But it's also on my unit circle. So I could just look it up on there. Now we didn't have the 4/3 on our unit circle because 53 degrees came out as kind of a decimal. So there's how that works. But if it's on your unit circle, you can go ahead and do that. That might be a faster way. And there you go.